It's a good evening, sir.
Sir.
Good evening, people. So I've been getting the privilege to teach you all twice so many times lately. Nice.
Yes, sir.
Morning.
OB quantum physics.
OB quantum physics, right? Such a privilege. And that too, with the feeling that you all are also looking forward for it. It's also that अरे यार
Yes, sir.
to class है. ऐसा वाला भी नहीं है. So
Yes, sir.
बहुत इंटरेस्टिंग है ना, तो इसलिए वैसे ही आ गया.
absolutely. Chalo, let's first recall what we learned in the last class. Okay. So because I want to take a question on that. So we understood that when we have infinite but unsymmetric potential value, okay, potential value, then the value of the function is always root of 2 by L sine n pi x by L. L or A, whatever we write. I think we wrote A a while ago, so I'll just write it A. So you don't have to write these things again. I'm just rewriting it. And the value of n here is 1, 2, 3, it goes on. But when we have infinite symmetric potential value, okay. Let's understand another thing. Unsymmetric does not mean anti-symmetric. Huh? That's different. Huh? So for example, symmetric means what? V of x is equal to V of minus x. Unsymmetric means they are not equal. That's it. They're not equal. That's it. But anti-symmetric, what is the meaning of anti-symmetric? That there is equality, but there is minus sign. Un is not anti-equal. English. Okay? Un is not anti. Anti-symmetric would be where V of x would be minus of V of minus x. Okay, so that's anti-symmetric. So write it very clearly. That unsymmetric is not anti-symmetric. Write it please. Unsymmetric is not anti-symmetric. So this becomes anti-symmetric. Like you can write it separately somewhere here. And anti-symmetric would be something like this, where V of x is minus of V of minus x. Okay. But this is unsymmetric. It means it's not symmetric. Not being symmetric does not mean it has to be anti-symmetric. No? Not being symmetric means it could be anything. Does not mean it has to be anti. It could be anything. Okay. So I'm glad that I think I'm trying to rewrite it. We just understood some English here. Okay. Thanks. And the value of sine of x here, we have two cases. One where it becomes root of 2 by a cos n pi x by a, and one where it is root of 2 by a sine n pi x by a. Okay. And cos is an even function. It means quantum numbers will be odd, 1, 3, 5. And sine is an odd function. It means quantum numbers will be even. That is how we always remember. Okay. When you say sine is odd function, it means it is anti-symmetric wave function. And when you say cos is even function, it means it is symmetric wave function. However, values of energy in both the cases, that doesn't change. It will remain n square pi square h square upon 2m a square. Also, you need to remember everything is same as far as width is a. Width cannot change. Width must be a. Like in unsymmetric, width must be 0 to less than x less than a. Like this is where V of x is becoming 0. V of x is 0 in this region. Okay. In unsymmetric potential value. And in infinite symmetric potential value, V of x is minus a, like V of x is 0 from minus a by 2 to a by 2. This is where V of x becomes 0. Okay. But width remains a. In both the cases, again, you can write in both the cases, width remains a equal. Width of box. Copy this one, take your time. Like add these things. We already written these things. Whatever is missing out on this, add those. And important to realize is unsymmetric is not anti-symmetric.
So in the left side corner, you have written minus 8.
No, 0 to 0. Because it's unsymmetric, no? So unsymmetric means a regular money box. The one that on which we have taken so many beautiful problems of our favorite fermions, bosons, spinel fermions. I'm sure if you read that question in JAM, the first thing that you will do is smile, and then you will probably solve. Okay, equation on spinel fermions.
Yes, and let's hope that comes.
Let's hope. Right. Shall we done?
Yes, sir.
Others, like adding or writing. Next. So the thing is, a very good question that I would love to create on this topic is an MSQ, people, because that is where I think students will make a mistake. Like what I would have done is, in the question, I would have given you that it's a 1D symmetric potential box. I will write it somehow. Sorry. Why my tongue is twisting so much today? 1D box which is symmetric. Let's say from the range where V of x is 0 from minus a by 2 to x to a by 2. Let me speak slow right now until I think I'm speaking properly. 1D box V of x is 0 from minus a by 2 to x to a by 2. Okay. Next. What? And now in this, suppose they have given you that the wave function is given by 1 upon, let's say, root 3a into, or let me think, 1 upon root 5a into sine. Just a second, I'm thinking. If I want root of 2 by a, I should write root 5a inside the root. Okay. Let's say psi 1 plus 1 upon root 1 square. Okay, so it's not necessary that it has to be this now. 2 upon root 5a. I'm not thinking. Okay, 2 upon root 5a, psi 2 or psi 3, psi 4. Okay, psi 4, 2 upon root 5a, psi 4. And they're asking you a couple of things in this option. Suppose this is an MSQ. And one option would be, where they are giving you average energy. One option will be where they are writing, let's say, psi 4 is given by root of 2 by a sine 4 pi x by a. Okay. And one option would be again of average energy. Some value. One will be a correct value, one will be an incorrect value. Okay. And another option is, let's say, psi 1 is root of 2 by a sine 1 pi x by a. Many students would solve this question very fast. They will think, psi 1 root of 2 by sine 1 pi x by this is correct. Psi 4 root of 2 by sine 4 pi x is correct. And out of A and C, most of the students would know how to solve this question, and they will end up writing A or C, either of them, and they'll get the answer. But where is it that they will go wrong, people? If they have not learned symmetric potential very clearly, people, then you should realize B or D, either of them is definitely wrong. Because this question is of symmetric potential, minus a by 2 to a by 2. And in that we know that when you talk about cos is an even function. So that should be valid for all quantum numbers. Cos is even function. So that should be valid for all quantum numbers. 1, 3, 5. So do you think psi 1 can be sine? No. Psi 1 must be root of 2 by a cos by a. And this is where option D becomes wrong. But students will end up marking this because hardly many students really learn symmetric potential well. Okay, but psi 1 will be root of 2 by a cos. However, psi 4 is fine because this is even. If quantum number is even, then the function must be odd. That is what we learned. So sine is an odd function. So B option is correct. So, but D will be incorrect here. And out of your C, whatever is the average energy, that is also correct. Okay, we can calculate average energy, but first we solve this. Take your time. So I will purposely start with 1D box, but I will write potential and I will give the range just to see, if students are reading whether the range is symmetric range or an unsymmetric range. Also, just a second, have a look. In this also, if I would wanted to have more fun, I would have purposely made it minus a to b.
Yes,
Then
sir.
what will happen?
A की जगह 2 है.
2 हो जाएगा ना?
It means B is wrong.
Yes,
Because
sir.
A should have had 2a. In that case, answer would be just 2 pi x by a equal. The correct answer for psi 4 would be root of 2 by a sine n pi x by a, but a is actually 2a. So the answer should have been root of 2 by a sine 2 pi x by a, but we have given 4 pi x by a. In that case, B would also be wrong. Okay. Layer after layers. Okay. You are lucky that I'm not setting the paper.
सर रूट ऑफ 2 बाय a जो है वहां भी
हाँ, वो भी root of 2 by a
होगा ना.
होगा ना.
बाद में जो लगा था वो भी रॉन्ग था.
वो भी wrong था. मैं कहा ना. So layers after layers after layers. There are 3 layers in this. See? ठीक है. होगा ना, क्यों नहीं होगा? Absolutely. So that will be root of 2 by 2a actually, right? Sine of
4 pi x by 2.
upon 2a. Absolutely. This is the correct value of psi 4 in that case. If I would have written minus a to b equal. So you can write it if you want. First you copy this and then you just add. And then you just add if the range was minus a to a. I hope first you copied this. Let me write it. Okay. Just write down if the range was minus a to a. If the range was minus a to a, it means width is 2a. It means width is 2a people. It means width is 2a. Nice. Next. It means root of 2 by a sine 4 pi x by 8. That is actually root of 2 by 2a sine 4 pi x upon 2a. You have to write length here. Okay, so you have to take a length is 2a this time. This is your psi 4 in that case. Great. Okay, people. Chalo, next. I hope you have copied this. Let me write it. So now let's solve this question. Okay, let's solve this question. Let's find average energy. So they have given us psi n, which is 1 upon root 5a, psi 1 plus 2 upon root 5a, psi 4. By the way, there is a small mistake. Since I've written psi 1 already now, I shouldn't write a. Just 1 upon root 5 and 2 upon root 5. Make this correction, please. Make this correction. Just 1 upon root
Why
5.
is it wrong?
I think because psi already has root of 2 by a sine. No? It already has root of 2 by a.
Okay.
So, and I mean, I created this question, so it's wrongly created. It would have been correct if I had written, I would have given a sine function here directly. In that case, the dimension would be there. Okay. Now wave function is here, wave function is here, wave function is here. They're already dimensionally equal. How can I have an additional a's? No? I cannot have additional a's. They're already dimensionally equal. Just cancel the a's, people. I hope you understood why it is wrong. They're already dimensionally equal. Okay, you cannot have another a. So just cancel this. So first of all, is it normalized or not? Let's say we can write this as C1 psi 1 plus C4 psi 4. Okay. So C1 square plus C4 square. So that's 1 upon root 5 square plus 2 upon root 5 square equal. So that's 1 by 5 plus 4 by 5, which is 5 by 5, which is 1. So it's normalized. Again, this could also be one of the options in MSQ. Wave function, the given wave function is normalized, something like that. Okay. So that's there. Now let's calculate probability, people. How to copy this? Tell me if you're writing. Okay. Let's calculate probability that the wave function will have psi 1 or energy will land in E1, whatever. Energy will land in E1. So that would be C1 square upon C1 square plus C4 square. So that's 1 upon root 5 square. Denominator is already 1. So this is 1 by 5, which is 0.2. So automatically answer of P psi 4. There is the second one, P psi 4 or probability of energy E4. There is 2 energies, you can directly write 1 minus 1, 2. Okay. 0.8. Or you can also use C4 square upon C1 square plus C4 square. That's also fine, people. So I'm assuming you are comfortable with this, and hence I'm just
Yes, sir.
going through this essay without taking more efforts to explain. But you can always tell that, so please take efforts to explain. I don't mind. That would be so harsh, if a sir or ma'am is told. So please take efforts to explain.
Yes, sir, we can. Do that one.
I'm thinking if there would be a student who could have that much of daring. They have all the right to tell this, but it could sound a bit offensive, but it's okay. The student is telling clearly. That's why you are not taking more efforts. You should take more efforts. They are not understanding.
So can you do that to a teacher?
See, it would be very hard, but then it may depend. It may also depend on equation you share with them. And if you know that, the teacher would be hurt also. So it depends. But
Yes, sir, I think that's you can say.
फिर इतना बोल देंगे तो प्रैक्टिकल नंबर काट देंगे
अभी कॉलेज में तो नहीं करना है भाई, never.
सर हमारी टीचर्स बनती नहीं है
चलो आगे जाके बनाना पड़ेगा. But people remember the most important thing that will matter in your MSc, apart from everything else, is your equation with your teachers. Because MSc के बाद क्या? If you're planning for a job, then it's okay. Go give GATE exam or give whatever exam, Sparta exam, ERDU exam, SCOPA exam, get a job after your MSc. But if you're planning for PhD, then I hope you are aware that for PhD you require something called as letters of recommendation. Without letters of recommendation, you cannot get a PhD at a good institute. What are letters of recommendation? Basically, the colleges where you have studied, the teachers who have taught you, they will write a letter for you, and they will mail them or post them. This is the student, I have taught him or her, or the student has done a project under me, and I think the student has this much potential or caliber, and the person will be able to do it. Whatever it is, the teacher has to write a recommendation letter and send it to the respective university. So suppose if you want to go abroad and do your PhD from Cambridge or let's say from MIT, or even if you want to do PhD from India from TIFR also, you will still have, you still have to give letter of recommendation. And no matter what, many students think the BSc teachers का भी letter of recommendation चलेगा. But the thing is, you can provide your BSc teachers का letters of recommendation, but it won't be that impactful. Because when they know that student is coming from NIIT or NIT, why the student is giving letter of recommendation of BSc? Then you will be like, the person has not done good in MSc with the teachers, and hence most importantly that will matter in your MSc is your equation with the teachers. So anyway, I don't think hardly students bunk lectures during MSc because you don't have option of classes anymore. And plus lectures are fun actually during the MSc, so you don't really bunk, and there is no option also. It's not that now you can bunk and just learn and pass through. It's unlike BSc this time. Especially if you're in a very good institute people, you automatically attend the lectures. But apart from attending the lectures and being active, it will be very important that you interact with the teachers and create a good equation with them. So for example, in our class also, around in general, in total 30 of you have said in bits and parts. But out of those 30 of you, I have been able to develop an equation with I think 7 or 8 of you, whom I can recall the name. That does not mean that I don't know this. I know others, but I don't know much about them. if you are going to ask me, suppose if I would be a college teacher, if I have to write a letter of recommendation for you, I know that you are an attentive student, you are always there in the class, I will write those things. But then if a teacher shares a good equation with the student, then automatically teachers would put more inputs in the letters of recommendation. So apart from being regular in your colleges, in your MSc, ensure that you start developing equations with the teachers, interact with them. Okay? Even though you have to act people, but act. It will be important for your career. Okay. Little things that I don't know who will tell you later, so it's better that I tell you now.
Thank you, sir, for sharing such information.
Arey, koi na. We can keep these sessions after jam also, like we just one day discuss about the lives of IITs.
Yes, sir.
Time pass gossip करेंगे. We'll just
Yes, sir, yes, sir.
official gossiping lecture रखेंगे. I will ask them that even staff members can also join and we can just interact. So that's fine.
Yes, sir.
Proceeding ahead. So this is done. What about energy? Energy doesn't change. Even though the wave function changes, I've already told you, energy will remain the same. So energy of the first state, that's n square pi square h square upon 2m a square. So that will remain 1 pi square h square upon 2m a square. Okay. And energy of the fourth excited state, that will also be 4 square pi square h square upon 2m a square. Or you can say it's basically 4 square into E1 people, or I can say n square E1. So my average energy, 16 E1. Okay, so my average energy, what is the formula, people? Probability of E1 into energy of E1 plus probability of E4 into energy of E4. So probability of E1 would be 0.2, energy of E1 is E1, probability of E4 is 0.8, and energy of E4 is 16 E1. We have calculated this, probability is 0.2 and 0.8 respectively. Okay, and you can keep E1 as it is, and E4 will be n squared times E1. I hope you remember this. We have learned En was n squared and E1 for 1D, n squared by 2 for 2D, n squared by 3 for 3D people. Okay, but in 2D and 3D, the problem was that n squared was that n was not quantum. Then you have to take care of the jealousy table. Okay. But anyway, so our answer is now 0.2 E1 plus 16 into 0.8, that's
12.8.
12.8, absolutely. Even, and 12.2, 12.8 plus 0.2, that's 13 people. 13 even is the answer. Okay. Sure. So the best part is, if it's symmetric wave function or if it's symmetric potential well or anti-symmetric potential, unsymmetric potential well, doesn't matter. Energy, the calculation of energy is not affected. Only the wave function will be affected. But take care of that. And hope that you can create a good question from it, because in other questions, many other students will also be able to get the marks, but this is where you can also get an HP, because we have learned symmetric potential. Sure. So this is also done. So actually, after this, what I would have done today, because this lecture is an additional lecture that we are having. So basically, tomorrow what I would have done is I would have directly started with hydrogen atom, but now we have an amount of time, so we can take another potential. Let's take another potential before starting with hydrogen atom. We have another lecture now, so good for us. Done, people? Chalo. Please give heading. Now, finite square wave potential. Finite square wave potential. So listen, 1D box was infinite potential now, and now we are basically taking a box problem only, but finite. In this also, I'll directly take the complicated case. I will take the anti-symmetric case. Okay? Sorry, I'll take the symmetric case. Okay? So I will take finite square wave potential, or I will just write finite symmetric square wave potential. Let me take this case. Okay. So what is the difference basically? Last time when we took infinite square wave potential, it was this. This is infinite symmetric square wave potential, 1D box. But the one which was symmetric. But now we want to make it finite now. It means what, people? Okay. After this, it has to become constant. It cannot be infinite. In region 1 and region 3, potential is not infinity now. Now it is finite. Now in this also there could be many layers, people. Sorry, I don't want to confuse you more. It's already an additional case. I'll just draw it. So what do we have? This is 0. Okay, they are mentioned symmetric. So RHS is a by 2, LHS is minus a by 2. Okay, and if this is V0, then this is also V0 people. I hope this is clear. And in between, what do you have? Vx is 0. Okay, so here you have Vx is V0, and here you have Vx is V0 people. So this is a region 1, this is a region 2, and this is a region 3. Finite symmetric square wave potential is this. Now listen, we did infinite symmetric square wave potential where this was extended till infinity, and region 1 and region 3 were useless, because for infinite potential wave function cannot exist. So 1 and 3 were useless. But now we have 3 regions this time. Okay, copy this. Take a time. So I'm trying to make it as complicated as possible so that we can have a very general case. Okay? So first of all, I'm taking finite square wave potential. In finite also, I am purposely taking symmetric so that we learn more in this. And again, I will purposely take the case of E less than V0. Let's take this case. It is getting as complicated as possible. Okay? We're taking the case of E less than V0. 3 important terms: finite, symmetric, and then E less than V0. These are the things given to you. So what do we plan to learn in this? Just derive the wave functions. That is the very end. But we want to find wave functions in region 1, 2, 3. Nothing else.
Here E is less than V0. What do you mean?
That's given
Wave function.
Wave function. The energy of the wave function, that's less than V0. Energy of the particle, that's less than V0. Okay. Chalo, people, done. Next. So let's start. First, let's describe the potential. So Vx, people, it is V0, it is 0, and it is V0. It is V0 for x less than minus a by 2. It is 0 between a by 2 and minus a by 2, and it is V0 again for x greater than a by 2. Here I should have x. Okay. I just described V of x, the thing that's written graphically. For less than a by 2 is V0, for greater than a by 2 is V0. Okay. So for less than a by 2 is V0, for greater than a by 2 is V0. And between minus a by 2 to a by 2 is 0. So between minus a by 2 to a by 2 is 0. Remember, it's discontinuous. Potential is not continuous. There is sudden jump. However, since potential is finite, wave function will be continuous. Actually, I think there is a small error that we made in the previous one. Hang on. 27 now. At the very beginning. Here, people, there is an error. Please correct this. The rectangular potential there at the start of today's lecture, the first lecture. Potential is finite, then the wave function is continuous. It's not finite, people. It cannot be continuous. You cannot have equality here. Remove the equality, please. Here it's fine because it becomes infinity. Sorry, not this one. Not this one. Where is that one? Infinite one that we took. This is fine. This one. Symmetric infinite potential well, people. 1D box. Go to that page for the first class. Symmetric infinite potential well, symmetric 1D box, people. The first class, the evening class. There is a small error that we have done out of happiness. So here I think we have written this. Look at this. Wave function, it becomes 0 at minus a by 2. That's correct. Okay. Because at minus a by 2 it becomes infinity. Okay. It becomes 0 at a by 2. That's also correct. Because at a by 2 or L by 2 it becomes infinity, but it cannot be continuous. It cannot be continuous. because wave function becomes infinite. So here you have to remove equality. Remove this equality people here in the middle region. It cannot be continuous. Okay. Very important. It cannot be continuous. I hope you understood and made the corrections. Okay. Wave function is continuous only when potential is finite. Here it is infinite. Yeah, it cannot be continuous. Okay. Chalo. Next. Now let's go back to what we were learning. Tell me if you have any questions here. Okay.
Sir, please go to the same page.
Same as in those. Okay, wait. This one. This one.
Yes.
Hmm.
So,
bolo.
size equals to 0, x less than equal to minus a by 2. That is also unequal sign.
No, that's fine. Wave function becomes 0 because it is becoming infinity. No? At minus a by 2 is becoming infinity. So wave function becomes 0 immediately. And that is the computation we use also. No? In the derivation, if you remember, we wrote right at a by 2 wave function is 0. Do you remember? We wrote now at a by 2 wave function was 0. At a by 2 means what? If x is a by 2, then wave function is 0. That is the only condition you use, correct? Are you confused? Tell me. Sorry. Sanju,
No, okay, sir, it's okay.
tell me one thing. Here, it is becoming infinity or not at minus a by 2? Infinity, no?
Yes, sir.
At a by 2 also it's infinity, no? Can wave function exist? It cannot. It means wave function must become 0. कहाँ पे? Equality at minus a by 2, equality at a by 2. But then you cannot say wave function exists. Here you cannot apply equality. No? Here I cannot. If it is becoming 0, it will either become 0 or it will be psi. How can it be both? समझा क्या? It cannot be both. No? So here I cannot apply equality because it is either 0 or psi. But it is definitely 0. And this is the boundary condition we use also while solving. That at x equals to a by 2 wave function is 0.
Yes, sir.
But see, even though you are understanding this and I'm teaching you in this depth, it's very unlikely that a good question literally on equalities they will make. If they make it, I will salute them for that because it is a very critical thing. And no book has given this thing in that with this clarity. Okay? But it would be a very good question if they make a good question on equality. Okay? But people, I hope you still understood this. Tell me about it. Okay? Chalo. Where is lecture 28 and this one? But here, as far as potential is finite, wave function now it is equal. Now we can have equality. So psi of x, it will have psi 1 value, it will have psi 2 value, and it will have psi 3 value. And it will be continuous too. So now we can have equality. Okay, minus a by 2, and then a by 2, to minus a by 2, and then a by 2. And by the way, what we wrote just a while ago is the same thing we have written in the first initial boundary box. Check. There we have written it correctly. The first initial boundary box that we took, there we have ensured that we write equality, we don't write equality, and then we write equality. We have ensured that. Just today we did this one mistake at least. Clear, people?
1 minute.
Take your time.
Yes, sir, please move on.
Next. So now we just want to find psi 1, psi 2, psi 3. Okay, so let's start with region 1. What do we have? V of x is 0. I think we will not 0, sorry. V of x is v0. No? In region 1, people, V of x is v0. In region 0, also V of x is v0. I think we can later use similarly word for both percent. Okay. So what is our potential, people? And what is the condition? We are using the condition E less than v0. Sorry. Just a minute. Okay. So what do we have? D square psi upon dx square plus 2m upon h square into E minus v into psi. This is 0. But we are talking about region 1, so let's write psi 1. We have d square psi upon dx square psi 1, okay, plus 2m upon h square. E minus v, v is v0. Okay, so E minus v0 into psi 1, this is 0. Now, since E is less than v0, I cannot write this as k square, people. You know why? Because otherwise k will become complex. So let's take minus common. If you take minus common, this becomes minus 2m upon h square. v0 minus E into psi 1, this is 0. Okay. So what do we have now? We can say let k1 square be equals to 2m upon h square into v0 minus E. Okay. Because v0 is greater than E now, v0 is greater than E, correct? They have given us here. It means k1 will be positive. Otherwise, it would have become complex, people, if you wouldn't do this adjustment. Okay. Topic. Take your time. I was still stuck somewhere thinking, confused.
No, sir, no, sir, no, sir.
Move on, okay? Move on. Chalo. D square psi 1 upon dx square minus this whole thing is now k1 square, people, into psi 1. This is 0. So d square psi 1 upon dx square. Or let's write this as d square psi 1 minus k1 square psi 1. This is 0. So d square minus k1 square into psi 1. This is 0. So d square is k1 square, or I can say d is plus or minus k1. We have got real and unequal roots, people. So our wave function psi 1 is c1 e raised to just k1x plus c2 e raised to minus k1x. Whenever you have real and unequal, what is it? You write c1 e raised to m1x plus c2 e raised to m2x, people. So m1 is actually k1 and m2 is actually minus k1. Plus or minus k1, people. So that's psi 1. Ask me if you have any questions. Don't hesitate.
Sir, can we write here as psi 1 is equal to e raised to alpha x? That form.
No. That is for when you have complex. No, you don't have complex. No? You write e raised to alpha x cos k cos beta x plus sin like c1 cos beta x plus c2 sin beta x. When you have alpha plus or minus beta I. Do I have complex on the I right now?
Yes.
So you can do that. So this is real. Now k1 is real. Minus k1 is also real. Now, but k1 and minus k1 are unequal. So whenever you have real and unequal, you write c1 e raised to m1x, c2 e raised to m2x, m1 and m2 are the roots. m1 is plus k1, m2 is minus k1. Okay? Sure.
Yes, sir.
Next. Proceeding ahead. Let's talk. I will use similarly. In region 3 also, do you think anything will change except the constants? Again, I will keep C3, C4 for region 2. I'm using C5 people. K1 will also remain same. Why? Because nothing is changing now. Even because in region 3 also you have V0 potential people. So potential is not changing. Okay, so the idea will still remain same. C5 e raised to K1x plus C6 e raised to minus K1x. You can write because potentials are same. So the wave function will also be same. But probability of finding a wave function that will change people because obviously decay has happened or whatever has happened. So constants will be different. But the wave function proportionate, like the dependency on x, that doesn't change. But probability of finding the wave function, that will absolutely change once you enter the region. So C5, C6, you will have new constants. Done. Next. Proceeding ahead. Now let's talk about region 2. That's where more interest lies. Okay. Region 2. So what is region 2 this time? V of x is 0. From where to where? Minus a by 2 to a by 2. Sorry, no equality. Minus a by 2 to a by 2. Now, this is symmetric potential V2. It means wave function should be what?
Either
Symmetric or
symmetric, yeah,
antisymmetric.
Does happen. Wave function must be either symmetric or antisymmetric. Nice. I'm being sad right now that Pantu is on the verge of end. Done, people? I mean, and then of your syllabus. It's never ending, though. So next. Let's solve this. So we already know the answer of this, but still. So t square psi upon dx square plus 2m upon x squared square into e minus v psi. This is 0. But the thing is, v is 0, people. Okay, v is 0, and psi is psi 2 this time. So you have d square psi 2 upon dx square plus 2m e upon x squared square. Okay, v is 0 and psi, which is psi 2. So what we can do is we can write that again, like k2 square. Okay, k2 square is 2m upon x squared square. People, another different thing that is happening this time is usually k1 was this, and k2 was 2m into v naught minus. But in this particular problem, k2 is this, and k1 is 2m into v naught minus. But earlier in all the problems we have taken, k1 used to be 2m upon x squared square in all the problems. But this is the first time I think k2 is becoming 2m into e upon x squared square. Okay? So the point is, don't by heart that k1 and k2 are always this. It will depend in which region you are. Okay. Sure. So what do we have? D square psi 2 upon dx square plus k2 square psi 2. This is 0. Okay. And we already know the answer to this. At the end, we will end up getting d is, or let me write it because I want to use cos square formula again. So d square plus k2 square into psi 2. This is 0. It means d square plus k2 square is 0. It means d square is minus k2 square. People. It means d is plus or minus under root of minus k2 square, or you can say d is plus or minus ik2. Now the student was asking, now we can use that e raised to alpha over the formula because they are complex this time. Okay. So by the way, the recommendation letters that I was talking about, only college teachers are allowed to do that. Classes teachers cannot give the recommendation letters. Just telling you that, just in case by any chance you thought for a second or assumed for a second. Only those who have taught you legally as in, even this is legal, but government point of view or whatever. Anyway, because Iran is actually private limited only, this is also legal, but still, academically. Done, okay? Let me finish writing. Okay, so d is plus or minus ik2. Okay, so I can write alpha plus or minus I beta. So now you can say that, see, the question right now, if you are thinking, sir, which formula to use? Should we use e raised to ik1 formula? Should we use alpha, like cos and sine? This is symmetric one now. If you have symmetric, go with cos sine. If it was unsymmetric or something like that, we could have, used something else. This is symmetric, let's go with cos and sine immediately. Okay, so what's our wave function? Psi 2. It's e raised to alpha x. C1, C2 is used, C5, C6 is used. We have kept C3 and C4 here. Yes. So this is C3 cos beta x plus C4 sine beta x. Okay, so e raised to alpha is 0. Okay, e raised to 0x. C3 cos beta is k. X plus C4 sine beta is kx. E raised to 0 is 1. So we have got C3 cos
K2.
K2.
C4 sine kx. So now I'll just add k2 everywhere. K2, 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 K2. Do you have a nickname like K2 with 2 here? Anybody?
Chotu.
It is never the reverse name.
K2.
Yes.
K2, K2 is there. K2. Now K2 like.
K2, that is a K2 now.
How like pronunciation? Our Hindi pronunciation becomes K2 now. Now K2 like K2. Yes.
That's not what I'm trying to say.
What?
So that is a range of mountain named like K2. God is asking.
Very general knowledge. But I know I have read this, but after ages I'm recalling this. The K2 mountain. Okay. Okay, chalo, next. Proceeding ahead. So what do we have, people?
I also know the Kharas effect.
Yes.
बहुत अच्छा चलेगा.
They are in the class actually.
Okay. Okay. Let's recall psi 1 physics. What is psi 1, people? Psi 1 was C1 e raised to k1x plus C2 e raised to minus k1x. Then psi 2 is C3 cos k2x plus C4 sine k2x. And psi 3 is C5 e raised to k1x plus C6 e raised to minus k1x. Okay, very interesting. Take your time, 2 minutes again I'm giving you. Think about the terms becoming 0 or whatever. Take your time. Don't tell me, just write it in your notes. I should have used stopper this time. Shit. Stopper use करना. पहले लगा देना, तब तो आधा हो गया, ठीक है. Next time on wait. That's all.
एक मिनट के लिए लगा दो.
नहीं अभी जाने दो. मैं गिनता हूँ. 30, 29, 20,
अरे रहने दो.
27. Okay, I'm just checking. As soon as it becomes 37, I'll stop. Okay, let's get started. No wasting time. Okay, so I hope you have taken an attempt. If you are still attempting, you can tell. Sir, we are still attempting. Okay, so let's do this. So to start with, let's talk about psi 1. People, you have k1x and minus k1x. These are real terms. They are not complex. You don't have ik1 and minus ik1. So you cannot use the concept of plane wave. You cannot use that incident reflection by any chance you have used it. You cannot use it. It's not ik1 and minus ik1. So here you have to use infinity and non-infinity wala stuff. Okay? What is the boundary? Minus a by 2 is minus a by 2 a problem? No, you write minus a by 2 not a problem. You write minus a by 2 not a problem. But minus infinity.
Minus infinity.
So if you write minus infinity, here if I write minus infinity, it's fine. because e raised to minus infinity, it means anything upon infinity, this becomes 0, not a problem. Zero wave function can exist. But here, if you write minus infinity, then what becomes? This becomes infinity. Minus into minus. Now you already have minus people. I repeat, if you substitute x as minus infinity here, you already have minus, 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 it becomes plus. So this becomes infinity. Anything raised to infinity, the whole term becomes infinity. Wave function is becoming infinity. That is absurd. It means this term cannot exist. Take your time, process it. Those who made a mistake here, correct it right now. And you can tell me if you want me to re-explain. Right, why it cannot exist? Because if you substitute x as minus infinity, this term is making it infinite, people. Not allowed. Okay. So we have only this term, people. Only this. Next. Proceeding about this. This is fine. Minus a by 2 or a by 2 both can exist as of now. So minus a by 2 is not a problem. However, the only important thing in side 2 is its symmetric potential. So actually both of them simultaneously cannot exist. Either cos will exist when it's symmetric wave function, or sine will exist when it's anti-symmetric wave function. So the trick for side 2 is actually both of them cannot exist. You have to write either it's c3 cos k2x, either it will be this, or it will be c4 sine k2x. It will strictly depend on energy eigenvalue. We cannot know that unless we don't know energy eigenvalue. We don't know whether cos will exist or sine. But both cannot exist. Why both cannot exist, people? Because we learned it has to be symmetric or it has to be anti-symmetric. So this is your symmetric wave function, people. This is your anti-symmetric wave function. So the point is, if an exam I give you 4 options, which of the following 4 options are correct? And if one option is this, people, this is an incorrect option. If one option is this is an incorrect option. Both simultaneously cannot exist. Okay? So either of them has to exist. And if this is going to exist, you already know the rule. What should be the quantum numbers, people? For even, you will use odd quantum numbers, and for odd, you will use even quantum numbers. So that's also there. Okay. Now let's talk about side 3. Again, where did this go? Mouse. I don't understand. Mouse suddenly stops working here. Now it's fine. Okay. Next. So again, we don't have IK1 idea here, people. You cannot use incident reflection plane wave for idea. You again have to use real and infinity. So a by 2 is again not a problem. If you substitute a by 2, it's fine. We are getting some logical values. But infinity could be a problem. If I substitute infinity and infinity here, e raised to minus infinity is not a problem because this becomes 0. So that's fine. Wave function can be 0. But this, when you substitute infinity here, e raised to infinity, this makes this infinity. Wave function becomes infinite. This cannot be possible. So C5 is 0. So your answer is C1 e raised to K1x. That's Psi 1, people. Psi 1 is C1 e raised to K1x. Psi 2 can be either cos or sine. It cannot be both. First. That's important. So it is either C3 cos K2x or it is C4 sine K2x. But it cannot be both. And Psi 3 is C6 e raised to K1x minus K1x. Okay, that's it. So by the way, even though we write C1, C3, C4, they can write constant whatever they want. Don't be adamant. Like if you are getting C3, if they are written C2, right, that's fine. There is no rule on constants. You can write C alpha, C beta, you know, like so constants have no condition. You can write whatever you want. So write C1, write C2 also doesn't matter. Write C3, write C4 here. Constants are not important. No, I cannot hear. Akash, are you trying to say something? I think now you may have unmuted yourself by mistake. Okay, done, people. So this is it. This is the maximum they can go. Maximum level, people. Finite we have taken. Symmetric we have taken. E less than E naught we have taken. That's it. If you have been able to understand this much and getting the wave function, if you have understood, I think we will do any kind of wave function now. Sure. With this, we complete successfully the potential barrier kind of the section. All the related potential stuff we complete here. Okay. And now we just have one topic remaining, that's hydrogen atom. But again, before we start that, something very important again. People, in 1D harmonic oscillator, let's recall what was 1D harmonic oscillator. Let plus half x squared omega stuff. I told you we don't have to by heart the wave functions because it included legendary polynomials or Bessel functions or whatever polynomials, the heavy polynomials. So we don't study them. And hence I had asked you to by heart only the ground state wave function there. Okay, whatever was the ground state wave function, I personally have not by hearted it. I think it is a e raised to minus alpha square x square by 2. Alpha square is n omega upon x square. Yes, I remember it now. Okay, so yes, ground state. Kind of you remember. I mean, I've not by hearted it. It's just n number of times when you keep writing it now, so you get the photographic memory. We have written that somewhere. But anyway, so that is one you need to by heart. However, there is some interesting questions that I saw. I think in this paper probably, where you're not supposed to by heart the wave function, but you're supposed to know these things about the wave function. For an example, people in 1D box. Let's recall 1D box for a while now. Not harmonic oscillator, 1D box. What do you know about the wave function if you remember? Psi x when you plotted with x. This is infinity, and this is infinity. What do you remember about the wave function? This was easy one, no? Wave function used to
It's not degenerated and it has a standing wave theory.
Standing wave theory, you have to keep plotting basically. So this was a ground state, and first excited was like this, you know, and second was like this, correct? This was for n equals to 1, this was for n equals to 2, this was for n equals to 3. Just write it division. Just write it. This was for 1D box. We know this. So very similarly, even though you have not by hearted the wave functions, and we are not supposed to by heart the wave functions, we are supposed to know that for harmonic oscillators, how they look like. That's important. Okay, so that's what we are doing. I'm supposed to know. Just has asked a good question on that, so I'm taking that because I feel that the JAM has to increase their level. Now that there have been so many classes around JAM, you know, I mean, those days are gone when your preparation of JAM is sufficient. I mean, it is sufficient if you have joined the coaching institute, but by yourself, if you are doing, especially if you're in your final year, now it has become very competitive. I think I told you this whole story on the first day of my lecture week, but anyway, leave that. No more horses. So the point was only that you can expect JAM to increase the level of questions, people. Okay, that's what I feel. Next. So in 1D harmonic oscillator, even though they have not asked us to by heart the wave functions, we are supposed to know how they look like. But remember, n starts from 0. Absolutely, here it starts from 1 in boxes. In harmonic oscillators, it starts from 0. The first wave function looks like this. Don't draw it yet, and I will teach you a shortcut technique. The first looks like this. Okay. The second looks like this, people. Okay. The third looks like this. And then there is fourth, and then there is fifth. I'll also draw fourth and fifth. So I need to draw this small first. Okay. And then let me draw, or let me keep a boundary. Boundary is important. 1D harmonic oscillator. Okay, I don't know if there will be a boundary or not. I'm just trying. It's harmonic oscillator, it's not boxed. So the second one now. This is second. So this is for n equals to 1 basically. This is for n equals to 1. Then third. This will be n equals to 2. It looks like this. And then n equals to 3. N equals to 3. It will look like 1, 2, and 3, 4. Now, see, if you're thinking how it looks like there should be a pattern here, I'm not sure if you are able to decode a pattern of drawing this one. I mean, you have understood that thing, I'm sure, that you have a half loop here, one wave here, 1.5 wave here, and 2 wave here. But how exactly am I drawing this? So remember,
odd number वाले आपने उल्टे कर दिए.
हाँ, Exactly. So odd numbers, people, we have no reverse it. Okay. So this is the first one. Okay. This is the second one. And then third one you already know. Like when you will go to n2, n equals to 4, n equals to 6, n equals to 9. So you know the pattern. But when it comes to odd, if you're drawing this, you cannot draw this, you have to reverse it. Okay. Similarly, if you're going to draw this, people don't draw it, reverse it. That's one way to go about it. Good. Okay. Another one. Listen. So what you can also do is, suppose this is the way, people. Okay. Increase it in the opposite direction. Like we have been traveling in the forward direction usually now. So draw it in the reverse direction, like this. Done. After this, again draw it in the reverse direction. Okay. I'm not sure how compatible you have to draw it in the reverse direction, like this. Again draw it in the reverse direction. Okay. So first you will get the graph. Have a look. You got this. Now draw it in the reverse direction. Again draw it in the reverse direction. And then draw it in the reverse direction. Reverse direction will work. That's one way to go about it. And the point is how to understand the center. People center of like geometrical center is the center of this graph. What is the geometrical center? This is the center now. Like here you should have the center. Very similarly, where should be the geometrical center here? Somewhere here. So this will be the center. Where should be the geometrical center here? So this will be the center. Okay. And then where should be the geometrical center here, people? Like this is one wave, and this is again one wave. So this will be the center. The point is, have a look in the graphs. You draw the first one. Okay. Now predict the nature of the second. What will be the second? It has to look like this. The reverse direction. Go in the reverse direction. So if you go in the reverse direction, the point is this is one half, and left half, and this is right half. So where should be the center here? Center should be here. So just while drawing, ensure to draw the center. I hope that is first understood. Now that you have drawn this, what will be the third graph? Third graph will be this 1, 2, 3. But where should be the symmetricity? Symmetricity should be here, left half and right half. Again, left half and right half has been here. Once you are done with this, draw this. Again, where should be the symmetricity? This is one wave. This is the second wave. So here you should have the symmetricity once again. Just divide the length equally. That's what I mean. Just divide the length. Draw this, please. I try to explain. You can always send me to explain. Copy. The length should be equal basically on left half and right half. Okay. So for example, here you have got what is the length? Lambda by 2. Okay. So here you have lambda by 4. Here you have lambda by 4. Okay. What is the length here? Lambda, one wave. One wave means lambda, people. You can write lambda 1 if you want. So you should have lambda by 2 on the right side and lambda by 2 on the left side. The point is length should be equally divided. So here also whatever is the length, same should be on the length here. Here whatever is the length, same should be the length here. Length should be equally divided once you draw the reverse diagram. This is how we can remember. I hope you understood. Tell me from. The trick is basically just draw reverse and then divide the length equal. Have you understood this, people?
Yes, sir.
Yes, sir.
Okay. Reverse and divide the length equally. Right? Write it with clarity. I think all of you said yes only now. I'm not sure if somebody said it now. So please write that reverse idea and divide the length equally. Sure, next. And to confirm that our logic, by the way, another thing, this is I've never said that the amplitudes will be equal. I mean, we have drawn this, but it could also look like this, something like this. For example, this one you have drawn now. It could be like this also, like something like this also. This is still harmonic oscillator. In harmonic oscillator, nobody has told you that amplitudes are going to be equal. Here also, when you have drawn this, even this could look like this, like large, small, and then large, small. Then also the answer is correct. Don't care about the amplitude, just care about the peaks. So write it that the amplitudes may or may not be equal. Write it the amplitudes may or may not be equal. But this A1 and this A2 is not necessarily they will be equal. You could have had something like this also. Then also it's fine in harmonic oscillators. Amplitudes may or may not be equal. So here also when you have drawn this, amplitudes may or may not be equal. It could be like this also, like just one peak, another peak, and small peak. Even this is fine. This is still a harmonic oscillator. Amplitude
Then what should we look out in this graph?
So basically what they will do is they might just give you a graph and they might ask you find the corresponding energy of this harmonic oscillator. So for example, I will just draw a random graph. Wait. Then people?
Yes, sir.
Sure. So just for a question, if you want to create, they're giving you that it's 1D harmonic oscillator. So kind of question that was asked in test. Okay. And they had asked find energy. Find energy corresponding to wave function shown. Corresponding to wave function shown. So even though we are not supposed to by heart the wave function, like I said, we are supposed to know how it looks like. So wave function psi of x and x. So suppose if I create something like this, I'm just thinking randomly. I'm not sure how correct is this, but just thinking. By the way, just a second. No, this is incorrect at the moment. At the moment, it's incorrect. What about the length? Let me check. 1, 2, 3, 1, 2, 3, 4. I need another one. Now it's fine. Okay. Random amplitude. So just I've drawn an amplitude randomly, but you need to understand what is the value of n here now. So how do we understand this? Don't waste much time. Start from here. Start from here. Look, this is 1. This basically, and you can count like this. N equals to 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. Just keep on counting like that. Or keep on filling. Like this is 0. Okay, then you can say 0, 1. Then you can say 0, 1, 2. And then you can say 0, 1, 2, 3. Keep on filling. So n is 3 basically. N is 2. Where you
एंटी नोट से कम कर दो ना.
However, you create your own tricks. The point is you create your own tricks. Okay. So for example, 0, 1, 2, 3, 4, 5, 6, 7. Answer should be 7. Or like you said, anti-note say come, but anti-note say come. You have got one anti-note here, 0. That's fine. And this is also fine. Count number of anti-notes. That's also fine, absolutely. So do we have 8 anti-notes right now? Because I got 7. 1,
Yes,
2,
sir.
3, 4, 5, 6, 7, 8. Chalega. Anti-note minus 1. Good trick.
Same here.
Create your own trick.
We are
Okay,
talking about these things.
it's same thing. Basically, number of loops or number of anti-notes. It's one and the same. Exactly. So you can write that n is basically we can say number of loops minus 1. So we are creating our trick, people. Nothing like this is exclusively present in the book. So you remember number of loops minus 1 or number of anti-notes minus 1, whatever. Okay, that's it. Okay. So n is basically 7. So what's our answer here? Energy would be what? 7 plus half x squared. So this is 7 to the 14. 14 plus 1 is 15. 15 by 2 x squared. Very tricky question, you know. But nice. Easy but tricky. Provided students are not this. Anyway, just to make you understand this, I have the list of Bessel functions of this, what do you call it, harmonic oscillator. We can check one of those on Desmos right now. I will plot the wave function and you have to tell me that which n it is. Okay. Let's just verify. I hope you have copied this.
Formula of En.
Pardon?
What is the formula of En?
Harmonic n plus half x squared. When harmonic oscillator?
But say you wrote n equals to loop number minus 1. So 6 होगा ना?
No. Total loops are 8. total loops are 8. 1, 2, 3, 4, 5, 6, 7, 8.
We are counting.
I started from 0 so that we get n directly. समझा? I started from 0 so that we get n directly.
Okay, please question.
हाँ, no problem ना? Clear ना?
Yes, sir, clear.
Others, I hope you are not confused.
Yes,
This-
sir.
हाँ,
No, sir, we are not confused. I am only confused.
no, still, I still need to ask. It's fine. See, only some of you have been constantly talking with me, like I said. Others, even though they might have doubts, they are not probably not even speaking. I don't know that. So it's my responsibility to still keep asking. Anyway, next. So, for example, they have given us at value of psi n equals to 3, the third, what do we call this? Third excited state. Third excited state. Or you can
For
say-
the harmonic oscillator.
for harmonic oscillator, fourth level, okay, for harmonic oscillator, 1D harmonic oscillator. They have given us, it is given by, okay, C1 into AX cube minus BX into E raised to minus CX square. After solving, they get this. C1 and C are random constants, okay, and A and B are also random constants. So obviously we don't know how to plot this. We don't care about this. What do we have, people? Third excited state. Without watching upwards, take your time and plot this first, and then we'll check on Desmos. Okay, and don't worry about amplitudes. Amplitudes could be anything that we can never predict. We need obviously a software to plot the amplitudes, okay? But just get a rough idea of how it should look like. Like I can give you 4 options in exam, no? And you have to mark the correct option. I can give you, let's say, an option like this, and maybe an option like this, and maybe, I don't know, an option like this, and maybe an option like this too. Who knows? So yes, these should be the answer in that case. We already just did n equals to 3 people here. N equals to 3. So these are the answer, okay? So 4 options will be given, and you have to predict which one is correct, okay? So let's check now on Desmos whether this is correct or not. Okay. You have to dictate me the constants, huh? Oh, no, I have it in my function. Just wait. Let me first open Desmos. Okay. So let me share the screen. Where is it? Are you able to see Desmos, people?
Not, yes.
Okay. So let's write the equation. Okay. So psi, yeah, I will write psi as y people equals to C1. Let's give any value to C1. Suppose 2. Okay. Into bracket. A. Let's give any value to A. Suppose A is 1 people. Okay. X cube. I'm just giving random values to the constant. X cube. Minus bx. So minus b. Let's give any value to b. Suppose 2. Okay. X. And then e raised to multiplied by e raised to. So there is a multiplication here. E raised to minus c. So let's say c is 1. X square. X square. What do you see, people? Hannah? Do you see
Yes,
what we expected? The 4 loops, 4 antinodes. Have a look. Okay. Obviously, amplitudes are small enough that will clearly depend on the constants, people. It will be small enough, but at the end you will have 4 loops like expected. Take a screenshot if you want. Okay. Chalo. Done. Understood?
Yes, sir.
Great. Next.
So can you show the slide which contains this graphs?
Sure. Okay. Where is our this? Yes, this one.
Not this one. You said the equation. Yeah. So actually, I thought it was C. So C and D are much more like very close. So
No, they are not. Because the thing is,
Reverse
this
start
one, yes, this one is starting reverse now. Like, it is starting like this, but the graph has to start like this. Always.
Okay.
So you always have to start from left. That's what I have told you. No? You will always go in reverse direction. But
got it.
purposely I gave C. Only this was the reason that I gave C. Yeah. Chalo, nice. Okay, so this is also covered. And now we have 15 more minutes now. So we don't have that much time to start with hydrogen atom because I'm going to take it at one flow. Maybe we can take a question here. I'm thinking. Okay, let's take a question, people. Okay. I have that question with me. I don't want to write it all. Just give me 1 minute again. I'll take a screenshot of the question, update it. Otherwise, if I keep on writing, it will take more time. It'll end the question. So you can go through what we are learning and just find the question. So what chapter is applications of solving the equation. Okay. Class. Click on the question. Taking the screenshot. Let me save it. Okay, that's done. And I will have to just restart open board. Done. Okay. Chalo, let me share the screen. Here we go. So this is what we did last. Let's take the question. People, the question should be saved already in the pictures. Q. Okay. Here's the question. Okay. Let's try to solve this. Okay. Consider a particle in the ground state of a rigid box of length A. Find the probability density mod psi x the whole square. Okay. So people, we have got a rigid box of length A. That's another thing. This is also interesting. Rigid means what? That a particle cannot go on that side. I already
Infinite potential.
Rigid means infinite people, infinite quantity. You need to realize this because rigid means you cannot enter the other region. That is basically wave function cannot go on that side. It means it's infinite potential, infinite box. Good. Of length A, find the probability density. Before finding probability density, we need wave function. So what is the wave function for 1D box? Psi n is root of 2 by L sin n by x by L. But they have clearly mentioned you have to study this for ground state. So ground state means n is 1. Remember, for 1D box n starts from 1. For harmonic oscillators it starts from 0. For 1D box it starts from 1. So this is root of 2 by L. L is A. Sine of 1 by x by A. So that's pi x by A. That's ground state. Probability density, that's time past p2 mod psi x square. So that's PV. That's nothing but psi star psi. But it's real anyway. So it is just psi square. So if you square this, root square is 2 by A. Sine square, that becomes sine square into pi x by A. Probability density, that's also done. Copy this mesh.
सर वन डाउट
पूछो।
सर ये कैसे पता चलेगा कि जो वेव फंक्शन है वो सिमेट्रिक है या फिर एंटी सिमेट्रिक है, साइन आएगा या फिर कोस आएगा?
अच्छा हाँ, because this is 1 now.
By default, you have
Yes,
taken it as asymmetric.
Only because it's not mentioned, like I have said, if they don't mention it, then we'll go for a default case. For this.
Okay,
Default case. Unless they mention it, you have to go for a default case. Okay. But obviously, remember, even if you go for the default case, it's not a standard thing. So it is their responsibility basically to mention. In Jam, they won't do that. They will always give you potential with equality sign proper and everything. They have to do that. So it's their responsibility to. Otherwise, you can always argue. And if you will, if
2
somebody,
marks.
2 marks will go to everybody. But you have to argue only if your answer is wrong. Okay, if your answer is already right,
Okay, sir.
then don't argue. Okay. Chalo. Done. But otherwise, it would be cos because cos is even, and for even we have odd quantums. Yes, that's there. Good observation. Next. Done. Deepu? Okay. So, sorry, the second part is not yet enough. The question is, where is the particle most likely to be found? Do you remember the shortcut trick to get this answer?
We have to plot the sine square and no, जहाँ पर amplitude maximum है तब जहाँ पर ये.
Yes. So do that. Tell me the answer then. V of x is infinity here. V of x is infinity here. And where is amplitude maximum? And box is 0 to a. Okay. So again, see, this is actually a good question because if it would be a symmetric box, then answer would be different. And for
Yes, sir.
then answer
Cos
is
में आ
still
जाएगा.
there. Okay. So yes, it's there. Yeah. So we are going with the default case though. Okay. So anyway, so for ground state, we already know the answer. We just have one wave for ground state people. If you remember, if you plot mod psi square, for ground it is just one. For first excited, you had 2 people. For second excited, you had 3. If you remember, I hope you are recalling this. Okay. Wave function looks like this. We are not plotting wave function. We are plotting probability density. So if you remember, in probability density, things just become everything goes in the numerator and not numerator. Everything becomes in the positive.
Positive direction.
But anyway, this is ground state. So where is it maximum? Where is maximum at a by 2?
A by 2.
Yes, it's maximum at a by 2. Okay. So just thinking, if suppose I would have given you symmetric potential and if I would have asked the same question, symmetric potential.
0.
So 0 पे होना चाहिए ना, minus a by 2 to a by 2, but first of all it's cos. But because it's cos, wave function looks like this, but it doesn't matter. Mod psi square. No. Yeah. No, wave function, because it's cos. This is weird. Wave function would be like when you draw, it's very complicated. This is sine actually, but this is just half wave that we get. And what about cos? Okay, let me think. So we have got wave function, just thinking of root of 2 by a cos of n pi x by a, and we have got cos pi x by a. So what happens at the boundary conditions? At minus e by 2 it becomes 0. So cos 0 becomes 1. First maximum. A by 2 also becomes maximum. Okay, it would be like this actually. Rather. It does not even become maximum. Thinking. It would be a very interesting question, but okay, let's keep it aside at the moment. But something that I should ponder upon and maybe come up with a good question maybe tomorrow in the evening. Let's see. Anyway, let's do this question right now. So it's better that we put the condition here x0. Let's add this in the question. Or take the default case unsymmetric unless it's mentioned. Next. Okay. So what do we have, people? Probability of finding a particle becomes maximum where is mod psi square maximum at a by 2. Okay. So the second answer is done. Answer is x equals to a by 2. Tell me if you did not understand this.
Otherwise, we have to take this derivative of mod psi square, right? And put it into
That's also there. That's also there. That always can work.
Okay.
That always can work. No problem. So next. So what is the probability of finding the particle between a by 4 and a by 4? So that for us we need to recall the formula. What is p of x, people? It goes from, like, if they are asking probability that the particle will be between. They have given a by 4 and k by 4 now. Okay. So how do we write this? When you write a to b, people, then you have to write a by 4 to 3a by 4. Mod psi square or psi star psi whatever dx the whole upon 0 to a of mod psi square dx. But this is already normalized. Denominator is already 1 because this is a normalized wave function, people, already. Okay, so don't worry about the denominator. Denominator is already 1. So you can just say answer is just a by 4 to 3a by 4, okay, of mod psi square dx, people, okay? Because denominator is 1. It's normalized, no? Tell me if you have any questions. Don't hesitate. Okay, shall we?
Sir, hold on, please.
Take your time. And this is a by 4. So when you go from A to B, basically, so here you have to write A to B, and denominator has all space. But all space basically means if they are giving you boundary, then take the boundary. They are given that the box is 0 to A, so you will take 0 to A. They have given us.
Yes, please, sir.
Okay. You know, this is makes me compare with a joke that you usually see, that a student would see a cow as a cow, but when you learn too much, you start defining the cow, that it has got
Yes,
more
sir.
legs like this and that and everything. So I mean, because we have learned so much that in such an easy question also, we start being critical, like, no, this should have been mentioned, and we confuse ourselves all the time. That
Yes,
this should have been done, this should have been done unnecessarily, and then our back of the mind that keeps on thinking this. Like right now I'm solving this, but now I'm not stable. I'm not very excited item right now in my head, but I'm constantly thinking what I have to do in that cos wala case. Learning too much maybe occurs also at times. Yes, it's boon also most of the times, but still. Chalo, next, let's solve this. Okay, so a by 4 to 3a by 4. What is mod psi square? We already have that. 2 upon a sine square by x by a. 2 upon a sine square by x by a dx. People, by the way, I'm solving this question for a reason. There is a very important shortcut formula that I have to give you for the fourth case, the D problem that we are going to do. Anyway, so first let's solve this 2 by a. How do we integrate sine square, people? Substitution. No? 1 minus cos 2x. That's sine square x.
Yes, sir.
Okay. So 1 minus cos 2x by 2.
2 sine square.
I wrote 2 here though. Okay, 2 sine square x. So 1 minus cos 2x by 2, that's sine square x. Okay. So what we can do is we can use that substitution. A by 4 sine square pi x by a sine square theta. That's 1 minus cos 2 theta by 2. Okay. So 1 minus cos 2, what is theta, people? Pi x by a by 2 dx. Basically 1 minus cos 2 theta is 2 sine square theta. 1 minus cos 2 theta by 2 is sine square theta. So here theta is pi x by a. So 2 theta will be 2 pi x by a. Okay. So you can cancel this to this too. We have got 1 by a. This goes from a by 4 to 3a by 4. A by 4 to 3a by 4. Integration of, we are just left with integration of dx minus integration of cos of 2 pi x by a. I hope you are with me so far. A by 4 to 3a by 4.
सर यहाँ ये हम बाहर नहीं ले जाते
कौन सा ए? ये
1/2 बाई ए
ले लिया मैंने, ले लिया।
नहीं लेना होगा ना, वो ए तो दिया है, कांस्टेंट नहीं है ये।
No, a is constant, a is length.
अच्छा हाँ x के respect में हाँ
No problem. Okay. So what do we have? 1 upon a into integration of dx, that's x minus integration of cos is sin people. So this is sin 2 pi x by a. But you have to divide by the constant. People, integration of cos theta is sin theta, integration of cos 2 theta is sin 2 theta by 2. So integration of cos 2 pi x by a is sin 2 pi x by a by 2 pi by a. You always have to divide by the constant in integration. Okay. This goes from a by 4 to 3a by 4. Okay. So we have got 1 upon a also gets cancelled by the. Okay. So we just have x minus 1 upon 2 pi into, sorry, a doesn't get cancelled. Too much of happiness. Huh? This is different and this is different. Okay. So it doesn't get cancelled. So we have 1 upon a into x minus a upon 2 pi into sine of 2 pi x by a. This goes from a by 4 to 3a by 4. Okay. So now we can substitute calculate time pass work. This you will do. Here I don't mind you taking it further. Upper limit minus lower limit. I'll give the final answer. This calculation you can complete. So answer of this will come out to be eventually 1 by 2 plus 1 by pi. Make a note.
Yes, sir, that's the answer.
Have you got it already? Good.
Yes, sir.
1 by 2 plus 1 by pi. Yeah. Chalo. But what is the next part that I wanted us to do? It's the part D people. Listen. What is the probability of finding the particle between 0.49 a and 0.51 a? Whenever you have small small regions, see a by 4 and c by 4, this is a large region. Like a by 4 is 0.25 times a, c by 4 is 0.75 times a. So this is a very large region. But for a very small region, I can use a shortcut formula, which we can always use, and that could be time saving, a literal time saving. But before I give you the shortcut formula, first use it. So first find the original value. So people don't think calculation will remain same, but only limits are going to change now. Okay. So for the last part, okay, for the last part, whatever part E or part D, whatever that is, same answer, probability. Answer will remain same, but you just have to substitute the limits separately. So 1 upon a, x minus a upon 2 pi into sine of 2 pi x by a. Now listen. Now the limits will change. For this, they have given us 0.49 a to 0.51 a. Let's substitute. Okay. So 1 upon a into 0.51 a minus a upon 2 pi into sine of 2 pi upon a x is 0.51 a. Upper limit is done minus the lower limit. 0.49 a minus a upon 2 pi of sine, okay, 2 pi by a into 0.49 a. By the way, a can be cancelled now. You can take a common.
Yes, sir, we can cancel.
You can take a common, a will get cancelled. Copy this fatapat and tell me honestly if you want me to explain anything. Don't hesitate. Okay. So what do we have? We have got 0.51, then minus 1 upon 2 pi into sine of a gets cancelled 1.02 pi. Sine of 1.02 pi. Okay. Then we have minus 0.49 plus 1 upon 2 pi of sine of plus 1 upon 2 pi sine of a gets cancelled 0.98 pi. Okay. So people 0.51 minus 0.49, that's 0.02. Okay. Minus 1 upon 2 pi common. Calculate this using calculator. Sine 1.20 and 1.02 pi plus sine 0.98 pi. Calculate this using calculator. Okay. Calculate this using calculator. Wait, I'll also check. Calculator now. Sine 1.02 pi. So what do we have? Sine 1.02 pi. That's minus 0.062. Minus 0.062 or 63. 0.627. So that's 63. And sine 0.98 pi. Sine 0.98 pi. So that's 0.0627. Actually, you will have to add it properly. I cannot do it. Otherwise, they will get cancelled because they are close to sine pi now. See what you are getting actually. Sine 1.02 pi. Let me add it directly with sine 0.98 pi. Okay. Actually, by the way, a common mistake. There is a minus sign. I have taken common here. Okay. So make it minus. Sine of 0.985. Okay. So we got a result minus 0.125. So divide it with this. So we have 0.02 minus minus plus. So divided by 2 divided by 5. We have got 0.0199, 0.0199, which is also giving approximately 0.02. So this is what 0.04. That's the answer. Got it, people? Ask me if you have any questions. Anybody? Are you alive? Hello?
Yes, sir.
Yes, sir.
Okay. So listen, what's the shortcut formula now? So maybe you're probably waiting for that only. Sir, okay. So the thing is, this is fine. Whenever you have small range now, so this thing can work. That is, probability can be written as mod psi a mean square into delta a. Works only when the range is small. Works only when the range is small. Sir, how small? See, smaller the range, accurate the answer, larger the range, error will be greater. So it's not how much. Use for 0.2, 0.4, 0.6. That is fine. Like for example, 0.49 to 0.51. Range is 0.02. Here you can use that. Okay. So what is a and am is a mean people, like a1 to a1 plus a2 by 2. And what is delta a? Difference people, a2 minus a1. So for example, in our problem, what we are supposed to do, let's calculate. Copy this fatapat. So for second one, it will work. For first one, this will not work. For the part D, this will not work because the range was a by 4 to 3a by 4. So that was a large range. So this will not work for this. The error will be large. Okay? So let's check. What is a mean? That's 0.49a plus 0.51a by 2, which is obviously 0.5a people, or you can say a by 2. So what is the value of psi x? Psi x is root of 2 by a, sin n pi x by a, sin 1 pi x by a. This they have given us. They are telling us you have to find the value of psi at this a mean value. People. What is a mean? A mean is a by 2. No? Find the value at this mean value. Understood? You have to find psi a mean people. Okay, so this is sine of 1 pi by a. What is x? X is a by 2. A gets
That's
cancelled.
root 2 by
pi
a.
by 2 is 1.
A by
So this is root 2 by a. Okay, and sine pi by 2, that's 1. Okay.
Sir?
हाँ बोलो.
सर रूट 2 बाई ए की जगह भी तो करेंगे ना a by 2.
No. Here I did not say a. A is only here. This is not x now. This is a only. You have to replace x with a by 2.
अच्छा सर, ओके ओके.
हाँ, you have to replace x with a by 2. ठीक है. Are you with me people until here, or do you have any questions? I hope you understood. Psi of x
Yes, sir.
is
Yes
you
sir.
just have to calculate psi a mean. So just replace x with a mean, which is a by 2. Nothing else. Okay. Next, what is the next part? Delta a you have to calculate. What is delta a? They have given us 0.51 a minus 0.49 a. A2 minus a1 basically. So this is 0.02 a. So what will be our answer, people? As per the given stuff, it is psi a mean the whole square into delta a. So this is what is sin a mean? Root of 2 by a the whole square into delta a. Okay. So this is 2 upon a into 0.02 a. A gets cancelled. Congratulations. 0.04. That was the answer.
Yes, sir. Time saving.
Time saving method. Okay. So we'll stop here, people. We'll continue tomorrow. Tomorrow we'll take hydrogen atom, and that should be it. That should be our journey together. But we'll meet tomorrow. So, thank you so much.
Thank you, sir.
No problem.
Thank you sir.
No
Thank
problem.
you.
No problem.
Thank you, sir. Good night.
No problem. Good night.
Thank you sir.
No problem. Shall I end the session? Let me try to reset.